Hi all, good afternoon to everyone. In the last session, we have focused the fundamentals, constants, variables, expressions, and then we have discussed how to find the area and circumference of a circle. Have you all gone through that materials and video session? Have any doubts? Lokesh, Harita, Meghavarshini, have any doubts?
No, sir.
Okay. In this session, we focus on solving some other problems that uses the scan-up, a print-up, and a processing statements. Please take the next problem. Next one, write a program to convert Celsius into Fahrenheit and Fahrenheit into Celsius, vice versa. So the problem is, given the Celsius value, we need to convert it into the equivalent Fahrenheit. And given the Fahrenheit, that should be converted into the equivalent Celsius. This is the problem. You know, for the first conversion, we need to have one input, that is Celsius into Fahrenheit. Celsius is given as the input. And the second conversion, a Fahrenheit is given as the input, that should be converted into the equivalent Celsius. Here we have the variables, the Celsius and the Fahrenheit. The variables should be properly defined. Then we need to get input values of the variables. The assignment statement should be properly written and it should be evaluated. Then the evaluation, should be printed. After the evaluation, we need to print the results. This is the flow, to solve this problem. You can also write the equivalent algorithm or flow chart. Start, input Celsius, convert Celsius into Fahrenheit using the computation formula, then print the equivalent values Celsius and Fahrenheit. So here, first we need to start with the header file, hash include stdio.h. Header file is included. Then we need to define a main function, int main. In the main function, first we need to define the variables. So declare the variables. Already we have seen how to declare the variables. We need to specify the data type, then specify the variables list. If we need more than one variables which are of same data type, we need to use the comma separator. In our problem, Celsius and Fahrenheit, these are expected to have the variables. So here I write the variables which are of floating point type, float. Celsius, I write in short shell, and Fahrenheit, FAR. This is actually the reserved word. So we can find FAR, This is in bold format. So I use for example, parent, short form, to indicate parent is a variable to store the actual Fahrenheit value. After the declaration of variables, what we have discussed in the last session, can you recall that before getting the input statement, what is expected to have conveniently?
Printf statement.
Yeah, try to give a reasonable printf statement so that whatever the message that you are given in the printf statement will help you at runtime. So here, first we need to enter the Celsius value. So write, please enter Celsius. Then Celsius, this will be obtained through the input statement. Please recall the input statement in C language is a scanf statement. Scanf. Then what type of value is retrieved, right? Required. Floating point value is required. So use percentage F format specification. Scanf percentage F. Then comma ampersand, the variable list is required. Ampersand, specify the name of the variable. Name of the variable is, for example, Celsius. That's all. The input is obtained right into the variable the Celsius. Then we need to convert right the Celsius into the equivalent Fahrenheit and Fahrenheit into the equivalent Celsius. So we know the conversion basically when a C is given, F can be computed. When F is given, C can be computed. Right? Since we know that F is equal to 1.8C plus 32, or we can write C is equal to pi by 9 into F minus 32. This is the required conversion 1.8C. So first Celsius is given, we need to find the value. F is equal to 1.8C plus 32. F is equal to 1.8C plus 32. 1.8, this is a floating point quantity. 1.8, right, can be written as 1.8. Then this multiplication is written as star C plus 32. We can write 32 as it is, or we can write 32.0. So 1.8 into C, this is evaluated in a floating point mode. Floating point plus 32 integer. Highest data type is integer. So type promotion is taken. 32 is type promoted to 32.0. So we can write conveniently F is equal to 1.8 into C plus 32.0. That should be returned here now. So here we write parent heat is equal to, I leave some spaces right to have right a clarity. Parent heat is equal to 1.8 star Celsius cell plus 32.0. Computation is over. Then we can print the result. Print of equivalent, right? Celsius and the Fahrenheit. If you want, Celsius is equal to percentage F. Then Fahrenheit is equal to percentage F. Don't specify ampersand symbol in the printf statement, but specify the variables in the order. First one is Celsius, second one is Fahrenheit. This is the case when we input Celsius and it requires to convert into Fahrenheit. In case if we like to input Fahrenheit, printf /n, please enter Fahrenheit. We write a scanf statement, scanf percentage f, comma, ampersand parent key. And Celsius conversion is okay. Edit, paste. Okay. The equivalent Celsius conversion is right. Celsius is equal to. Be clear here. What is our formula? C is equal to 5 by 9 into F minus 32. Normally 5 by 9, right? This is evaluated with respect to a floating point mode. In C language, if you write for example 1 by 3, 1 by 3 into 5.2, assuming that this is stored in a floating point variable, say float A, what happens? 1 by 3 numerator by denominator, this is evaluated in the integer mode because numerator is integer, denominator is integer. So 1 by 3 integer evaluation is 0 point fractional part 0.3333, this will be lost. Only integer portion is taken. So this is evaluated as the integer mode as 0. 0 into 5.2, this results in 0. To have the correct floating point evaluation, you need to give either in the numerator or in the denominator the real quantity. So if we type 1.0 by 3 into 5.2, here the numerator is 1.0 as a floating point quantity. Here this is the denominator in the integer quantity. Float by int means the result is converted to float by float. Type promotion is taken. So 3 is automatically taken as 1.0 by 3.0 division 3.0 into 5.2, so that the real arithmetic, floating point arithmetic is carried out. So here also C is equal to 5 by 9 into F minus 32. 5 by 9 is evaluated in the integer mode because numerator is integer and the denominator is integer. So we are writing conveniently either 5.0 by 9 or 5.0 5 by 9.0, or conveniently 5.0 by 9.0 into F minus 32.0, so that floating point arithmetic fractional values, right, will also be included. We are getting right the correct accuracy. Hence, this kind of evaluations, integer by integer, integer result, integer by float, floating point evaluation, float by integer, floating point evaluation, right? Int into float, floating point evaluation. So having int by int or int into int, right? In that stage, if you require actually the correct accuracy, you need to convert explicitly into a floating point constant. Hence here we write 5.0 by 9.0 star F minus 32, or I write 5.0 into numerator. Numerator is parent key to minus 32.0 division. Denominator is 9.0. So parent heat to Celsius conversion has been written in this equation. Cell is equal to 5.0 into within bracket parent heat minus 32.0 divided by 9.0. This equation is written there. C is equal to. Next, we can print the equivalent, right? Fahrenheit and Celsius. In case if you want to make copy paste, right? Select it, then go to edit, copy, control insert, then go to edit or keyboard shortcut, shift insert. Here I write, for example, Fahrenheit first, then Celsius again. This is equal to Fahrenheit, comma, Celsius. That's all. Finally, write into main, right, to avoid the warning messages. Let us return a value, return 0. That's all. Let us save the file. Previous file name is cp8. File save. Let's save as cp9.cpp, right, by default. Then check for compilation and running. I am pressing F9. Good, no compile time errors are reported. Control F9. We are having, right, this output window. Please enter Celsius. For example, I type 23.5. Celsius is 23.5 and Fahrenheit is 74.3. Please enter Fahrenheit. For example, I give 74.30003. We are checking, right, if we get the same Celsius value. Yes, that is Fahrenheit is 74.30003. Some accuracy, right, is automatically taken by the system. So that's what we can have, right? After the fractional part, the input value 0.30003 is taken as 0.300034, then Celsius, right, approximated to 23.5. Understand, in this example, we have illustrated what is a data type, right, floating point, right, variables. Cell and Fahrenheit are defined as floating point type. Variables are cell and Fahrenheit. We have illustrated the input statement, output statement, computational statements, and how to evaluate the expressions with respect to integer by integer mode. Right? Explicitly, we have converted to a floating point quantity. Have any doubts in this example?
No, sir.
Shall we move on to the next example?
Yes, sir.
Sir,
Okay. Yes, if you have any doubts, right, please interact.
sir, I tried writing yesterday's code in my Turbo, sir. It
Okay.
showed syntax error in the int main, sir.
What is a syntax error? What
Uh,
it reported?
like it showed a hyphen in the main, sir. Like syntax error int main. That second line we write, no, sir.
Do you have the code, right? Can you share it? Or tomorrow session, right? We have the lab session, right?
Yes, sir.
That stage, right? Tomorrow we have the lab session, Friday 1 and 2 hour.
Okay, sir. That time, okay, sir. That time
We
I'll
can
show.
write, yeah. Or after the session, right? You try to post the code, right, in the WhatsApp group. I check and tell you.
Okay, sir.
Okay. Next example, right? The CP9. Okay.
Sir, one more doubt,
Process.
sir.
Yes.
So initially, if we give float main means it will run off. Sir.
Initially,
Here we have given int main, no, sir.
yeah.
If we give float main,
As float, Bhargav, Sai Bhargav.
Sir.
In C language, program execution begins at the main function. There is a predefined standard defined for the main function. You see developers, right, developed the main function as returning the value which is of type integer data type. So there should be, right, no change in the return type of main function. We need to follow that skeleton, right? That we can say as a type signature as it is into main. If you try to give us float, right, that will be a problem.
Okay, sir.
Then write the next example. Find the sum and average of 5 numbers. Assuming that inputs are shall we have this one average of 5 integers. Okay. We have already written the algorithm, right? So hope you understand that input, read the integers, 5 integers, A, B, C, D, E, find the sum, find the average, then print the results. Let us try to convert the algorithm that we have written earlier into the C program. Hash include stdio.h. Usually I prefer to write in double quotes. I already said after E, space is also accepted, or instead of double quotes, if you prefer to use angle brackets, less than and greater than, no problem. This is also accepted. Then into main within this opening and closing curly braces, define the statements of main function. Integer, 5 integers, so shall we write as int A, B, C, D, E. Then sum is clearly the integer. So I write sum variable in the integer declaration. Float, right, average. You can use ABG or average as a meaningful variable. Variable declarations are over. So try to declare all variables, right, in the beginning of a main function section. This is required, right? This is another important point in C language. In these compilers, right, this restriction is necessary. Declaring all the variables at the beginning of the function definition. Whatever is a main function or user-defined function. Later we focus on user-defined function. As of now, right, we are trying to write all the code in the main function. But in some compilers, right, you can find wherever you need, you can declare a variable, right? I'll show it right later by running the code in some online compilers. Now, right, whatever the variables we need with respect to a main function, that should be declared or defined at the beginning of a main function section. Now, writing a printf statement, printf slash n, enter 5 integers. That's all. This is the message. So that at runtime it prompts to enter 5 integers. Then scan up how many integers we need? 5 integers. So I write basically format specifier, right, percentage d 1 2 3 4 5, then comma for 5 integers variable list is individually separated with the comma and ampersand operator. This is not ampersand a comma b comma c comma d comma e. This will not be accepted. For each variable, ampersand should be specified. Ampersand a, ampersand b, ampersand c, ampersand b, and ampersand e. Input is obtained, right, in these 5 variables. Next, we need to find, right, what is called sum. Sum is equal to, already we have written in the algorithm, a plus b plus c plus d plus e. Sum is computed. Average, average is equal to sum by, just wait, right, I tell you, right, all possibilities. What happens when we have sum by 5? Then sum by 5.0, that we need to think. Next, we are printing the results. Printf slash n, I use conveniently to print each line separately in a new line. Printf slash n, sum is percentage d, then believe, right, some space, you can use slash t. Slash t, slash n, right, this forces the output in a new line. Slash t effect is, right, it leaves, right, one tab, right, you can find, right, the spaces. After the spaces, one tab space, you can see the effect in the output. Average is AVER, average is percentage F, string is closed, first variable sum, second variable average, they have closed. Finally, we can use return 0 or 1, whatever is one integer. Let us save the file. File save cp10. First, let's
Sir,
compile it. Yes,
sir, the slash n should be given inside double quotes, sir. Or can we also give
yes,
outside?
it should. Yeah, it should be given in the double quotes, inside the double quotes.
Okay, sir.
Slash t purpose, right? Adjust you will see now. Compilation is over. Control F9. Enter 5 integers. 1 space, 2 space, 3 space, 4 space, 5. And find what happens. Sum is 15. This is the effect of slash t. This is to be horizontal tab. Horizontal tab, right, leaves these spaces, right? Then we can see the message average is 3.000 something, right? We need to ensure if this average is the correct one. In this example, 15 by 5, 3.0, right? No problem, result is correct. But we have the inputs like this 11, 22, 33, 42, 55, 165 by 165 by 5, 33. Okay, control F9, enter 5 integers 1, 5, 7, 8, 9. Sum is 30, 30 by 5, right? Okay. Control F9, 5 integers 1, 2. Okay. Now what is sum? Sum is 17. 1 plus 2 plus 3 plus 4 plus 7. That is correct. What about average? Average is 17 by 5, right? That should be evaluated. In our code, when we write average is equal to, have a look into this line. Average is equal to sum by 5. Average is equal to sum division 5. What happens? Sum is 17. 17 by 5. This is evaluated in the integer mode. 3.24. Am I right? Fractional part. 4 is 0.4 is lost. Only the integer portion is taken. 3 is the integer portion. 0.4 a floating point or a fractional part. 0.4, right? This fractional part will be lost. Only integer portion is taken. But the statement average is equal to sum by 5. Right hand side is the integer evaluation 3. 3 is further assigned to a floating point variable average. So we can see the output as 3.0000, right? After the decimal point, you can find 6 zeros. To have the exact fractional part accuracy, as we have 3.4, what changes are required in the assignment statement? What are the changes or what change is required, right, in the average statement? Average is equal to,
sum by 5.0.
yeah, very good. You need to give as some division 5.0. In this case, what in this case what happens? Our average is left hand side variable as it is 17. This is stored in the variable sum. Division 5.0, 5.0 here 5.0, this is a floating point quantity. This is the integer quantity. The result is evaluated as integer by float. Now what happens? Int by float means this is type promoter to float by float. So 17.0 by 5.0, you will get the fractional accuracy 3.4. So let us check the code again. File, save. First you close right the output window. Okay. Control F9. 1, 2, 3, 4. Then I think 7 is given. Now you can find sum is 17. Average is 3.4. As a fractional part, we have got the correct result. Understand or not? Understand or not?
Yes, sir.
Shall we move on to the next example?
Yes, sir.
Okay, next example, right? Please take it. Write a C program to swap two integers. That's all. Write a C program to swap two integers, right? To swap the two integers. Already we have written the algorithm hash include stdio.h into main. Please recall in the algorithm we have given two integers, input to two integers. Let us have, right, for example, int a comma b, a comma b, a comma space b, whatever is no problem. Printf variable declaration is over. Printf slash n, enter two integers x and y. Next write a scanf statement. Scanf percentage d ampersand x ampersand a comma ampersand b. A and b, right, are two integer variables which are receiving inputs from the keyboard interactivity through the scanf statement. If you want to avoid the scanf statement and initialize the values in the program itself, we can do that. Int a is equal to 5, comma b is equal to 10. Then we need to write the processing statement to swap a and b. We can write a is equal to a plus b. Then what is b? B is a minus b. Then what is a? A is a minus b. Print the values. Print of hash n after swapping. Print of hash n. I think a is equal to percentage d hash n b is equal to percentage d comma a comma b. Then return 0. Save the file. File save cp11 f9. No compile time errors. Control F9. Enter two integers x and y. Say 10 and 45. After swapping, a becomes 45, b becomes 10. Before swapping, x is 10, y is 45. Sorry, a is 10, b is 45. After swapping, right, the values of the variables a and b, these are revoked. The algorithm, right, we have already discussed. The same algorithm is implemented here. You can also replace plus and minus by star and slash operators, right, as we discussed here. Understand or not? Have any doubts in this example?
No, sir.
Okay. Now let us explore, right, the constants further. Next page. Please recall that constant is a quantity whose value does not change during the execution of the program. It can be a numeric constant or it can be a string constant. String constant you have seen, for example, hi, welcome, to learn C. Anything that is enclosed within the opening and closing double quotes, this is a string constant. We can use the string constants right inside the printf statement. Numeric constants are right which are of integer type, a floating point type. For floating point type, right, we have the keywords, right, float, right, and double. Float, right, single precision accuracy. Double, right, which having right more accuracy. Double precision accuracy. We can use those keywords, a float and a double. So far we used right a float, right, double also, right, we can use right percentage, right, a LD, right, double format specifier, right. For integer, right, we use percentage D format specifier. Floating point, we use percentage F format specifier. Integer constants, right, can be classified further, right. Decimal integer constants, which are using the digits 0 to 9. If you write int x is equal to 5, int y is equal to 0, by default, right, these are decimal constants. To have, right, another constant, that is actual constant, supported in C language. If we write int x is equal to 0, 1, 2, 3, what happens if anything, right, that is preceded the constant 0, mathematically 0, 1, 2, 3 is 1, 2, 3, but here x is the integer constant which is defined like this 0, 1, 2, 3, and if we try to print, right, this value x, 1, 2, 3 will not get printed. For example, let us illustrate with an example. Octal integer constant. I write a simple example, hash into stdio.h int a is equal to 1, 2, 3, comma b is equal to 0, 1, 2, 3. Printf a is equal to percentage d, comma a. Printf slash n, b is equal to percentage d, comma b. Return 0. Save the file, save, cp12, F9, no compilation errors, control F9. You can find the values. A is 123, no problem. B, right, we have obtained, since B is equal to 0, 1, 2, 3, you can see the color effect. 1, 2, 3, right, in one color, 0, 1, 2, 3, right, this is in another color. The color effect is, right, this is not a decimal integer constant, but this is an actual integer constant. How 0, 1, 2, 3 is printed as 83, 0, 1, 2, 3, this is equivalent to 83, 1, 2, 3, this is decimal constant. If you convert it into octal, 188, 43, what happens? Three, then 8, 180 is 123, right? 123, this is in, right, decimal mode. You need to convert it into what one? Equivalent octal mode. So here 1, 2, 3. 3 into 8 power 0. 3. 2 into 8 power 1. This is 16. 1 into 8 square. 64. What is the total? 83. So 1, 2, 3. This is represented as the octal integer constant. That is the significance of octal integer constant. That is the significance of this leading 0. So following that, the value, right, 123 as a decimal constant, that should be converted into, right, the equivalent octal 1. That's what here we have the result 83. Process is already ready. 3 is 83. Right? Likewise, we have another constant called in integer mode hexadecimal integer constant. hexadecimal. Decimal, right, uses the base, right? Then octal uses the base 8. Hexadecimal uses the base 16. 16 is the base for hexadecimal integer constants. In this case, you can write int x is equal to 0x 1, 2, 3. What happens? 0x. This is the prefix for hexadecimal integer constant. For example, the same right here I write int a is equal to b is equal to a, then uh, sorry, int a is equal to b is equal to, I write c is equal to 0x 1, 2, 3. Actual hexadecimal integer constants. Then I write printf slash n c is equal to percentage d comma f2 f9 control f9. C is 291. The C, right? Actual value of x is here 291. So 123, this is in decimal. To convert this into the hexadecimal, 3 into 16 power 0, 3, 2 into 16 power 1, this is 32, 1 into 16 square or 256. So this is 288 plus 3 or 291. That's what value of variable x is 291. We can also use 0 small x or 0 capital X. 0 capital X. Control F9 to get the same result. So understand, the hexadecimal integer constants are prefixed using 0 small x or 0 capital X. Like in octal, right? We need to have the digits 0. Following the digit 0, the allowable digits are 1 to 7. You cannot type, for example, shall we try right in the another line? Int d is equal to 0, 1, 2, 3, 8, f2, f9. Have a look into this compile time error. Illegal octal digit, right? Press enter. You can see the message here. Illegal octal digit in function main. So after the digit, right, 0, if it is the integer constant, allowable digits are 0 to 7, right? This is invalid octal constant. Likewise here, int some e is equal to 0 x. The allowable digits are 0 to 9, 1, 2, 3. Then you can use A, B, C, D, E, F. In this case, no problem because 0x, this is the prefix for hexadecimal integer constant. 1, 2, 3, A, B. What happens in hexadecimal? After the 0x, allowable digits are 0 to 9, then 10, 11, 12, 13, 14, 15. 10 is right, small e or capital A, 11 is B, 12 is C, 13 is B, 14 is E, and 15 is F. We can use small a to F or capital A to capital F. This is hexadecimal integer constant. Understand?
So why sir that is invalid? That D is equals to 0, 1, 2, 3, 8.
8, that's the reason I said that. 0 is the prefix for the hexadecimal, sorry, 0 is the prefix for octal integer constant. Octal means, right, base is 8. When you write divide, right, the base, right, or integer by 8, you can get the reminders, right, from 0 to 7. Minimum reminder is 0, maximum reminder is 7. That's what, right, only the allowable digits are 0 to 7.
Okay sir.
Okay, so just to have an idea, right, on these constants, right, how to find the valid constants, right, and invalid constants. So numeric constants are further, right, classified into these categories: integer, floating point, integer further, right, decimal, octal, hexadecimal. Another one is, let us finish with this topic, a long integer constant. Long integer constant. This takes, right, higher the range. For example, if you write int x is equal to 5, this is short integer because different data types are there. Int, float, char to store character types. Int is further, right, classified into signed int to store, right, the negative numbers. Then unsigned int, there is no sign, so it stores both positive as well as negative values. Then the signed unsigned, right, further classified as signed, short int, unsigned, short int, right, only the range will be differing. In case if you want to have the integer range is a large one, right, long integer constant is defined as int x is equal to, say, 5l. I try to write suffix a character l here. For example, int g is equal to 5l, f2, f9, no compile time errors. That means this is same as into g is equal to 5, but since this is the long integer constant, we need to have the data type as long. Preceding int, right, what I have done, typed a keyword long int. So 5 is taken as the long integer variable. It takes the range, right, more than that of the integer 1. Normally here integer occupies, right, 2 bytes. Char occupies 1 byte. 1 byte means 8 bits. 8 bits in the binary system. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. So having the values, right, in terms of zeros and ones, we have the place values 1, 2, 4, 8, 16, 32, 64, 128. So 128, right, plus these already, next value is 256 minus 1. So this stores a 255 as the maximum one in case of 1 byte range. Integer occupies 2 bytes. 2 bytes means the storage is 16 bits. So this is 1 byte. You can have, right, another 1 byte here, so that after 255, if you want to store the values, right, we can use a 2 byte storage. So since 16 bits, if it is not enough to store that integer result, Further, if you want to have the extended range, you can use long int. You can suffix like small l or capital L. You can also write long int h is equal to 1000 L. I put L as a capital one. That's check for compile time errors. So long int, right? Long int, actually long int is like percentage LD, not double, right? I said here percentage LD. This is for double, not double, right? Percentage LD. This is for processing, getting long integer input values. So this kind of long int, right? You can see the application later. For example, factorial. 10 factorial, 15 factorial, right, 25 factorial, that cannot be held in the range of right 2 by 16 bits. So we can use right the extended range long int. So basically, right, the constants, right, yeah, numeric constants, string constants, right, in that you can see integer, floating point, right, octal, hexadecimal, then long integer constant. These are supported. With respect to string constant, you can have anything that is enclosed within double quotes. Other than that, we have a character constant. Character constant. Let us complete right this topic. Anything that is enclosed within the single quote, that is a character constant. This is defined using the data type char. So far we have seen int and float. Other than int and float, right, char data type is available. We can write char ch is equal to small a. Char ch is equal to capital X. Likewise, anything that is enclosed within the opening and the closing single quotes. This is said to be a character constant. Normally, the character constants are taking the ASCII value, American Standard Code for Information Interchange, ASCII values, right? It takes 7-bit values. Here, small a to z, the ASCII values, you should remember, right? Small a to z, 97 to 122. Capital A to z, the ASCII values are 65 to 90. To verify that, we can write one statement. For example, I write in the same example, character ch is equal to small a. Here at the end, for example, ch not declared earlier, okay, print of ch is equal to percentage c ch, then print of slash n ch is equal to percentage d ch. Already we used percentage d and percentage f. Here I used newly percentage c. See the effect. F2 file save. Okay. Control F9. Finally, write last two outputs, please. Ch is equal to a, because a is a character constant that is placed here, right? Ch is equal to a. Then when we write percentage d, we can ask sir integer percentage d, floating point percentage f, character percentage c. These are okay. Why did he use ch? Ch is the character one, percentage d here. There is a question. Since character takes 1 byte storage, integer takes 2 byte storage, each character that is available in the keyboard all right, printable characters, right? Even non-printable characters are also there. All characters right in the keyboard are taking the equivalent ASCII values, numerical values. So character and integer are compatible data types. We can find the equivalent ASCII value of a character by printing in the percentage D format specification, because percentage D tells the integer output. CH is even A, percentage C is given, character A is printed. When you give percentage D format specifier, the equivalent integer is printed. So here we can find small a is 97. Likewise, you can check right capital A or capital Z, right? You can find the equivalent ASCII value. Capital A means 65, capital Z means 90. Likewise, for all the characters in the keyboard, right, 0 to 9, right? Then printable and non-printable characters, you can find right the way to print it using percentage C format specification. And to find the equivalent integer values, please use percentage D format specification. So in this session, right, we have explored right further having the variety of constants, numeric constants and the string constants. Have any doubts? Have any doubts? In the tomorrow session, right, I will focus on right the extended things, right. We can focus on right operators, expressions, evaluation of expressions, and then right we focus on solving the problems, right, that we have solved earlier, right, as the algorithmic conversion or the flowchart conversion. So basically, right, understand the structure of the C program, how to define constants, variables, how to define assignment statements, how the expressions are evaluated, particularly right the input statement, variable declaration statement, output statement, right? These are the fundamental blocks in writing the C program. So please go through this session right carefully. Tomorrow, right, we will solve right several problems in the first two sessions. Thank you very much.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.